Hello, dear students. Welcome to the second lecture of electrical drives. This is Jayant Mane from Finolex Academy, Ratnagiri. In the last lecture, we have seen introduction to drives and definition of drive, then some examples of drives, and this block diagram of electrical drive. Also, I have explained the different blocks of this electrical drive with some example. Now, obviously, in all these drives, the very advanced one and very popular one or being currently used in industries is electrical drive. So obviously it must possess some advantages. So here are the advantages of electrical drive. So first advantage is flexible control characteristics. Now control characteristics means obviously the speed and torque control, especially the speed control. So this has very flexible control characteristics. We can achieve any desired operating point which lies in the control region or controllable area of the motor machine. So as we know that the drives are used whenever there is requirement of variable speed and variable torque. So some operating point of any drive means a steady state point. So steady state point of drive means the drive running with some constant speed and delivering constant torque to the load. That is what the steady state point is, and that is the operating point of the drive. For example, suppose the load requirement is 10 Newton meter of torque at 1000 rpm. So that is, you can see, the operating point. So generally we know that we plot torque speed characteristics of machines. So on the characteristic we can choose the point of 1000 rpm, and on mostly the y-axis in drives, and on x-axis there is torque. So we can select the desired torque from x-axis and desired speed from y-axis. Just see where these two points intersect the motor characteristic, and that is the operating point. So it is having programmable characteristic, means we can have variable torque by maintaining the speed constant. Sometimes we can vary the speed along with the torque as per the demand of the load. So that is why it is written here, programmable drives designed using microprocessors and PLCs. They have desired steady state and dynamic characteristics. Steady state, I have explained you, the constant speed and constant torque operation, and dynamic is changing torque or speed operation. That is dynamic. Means suppose previously it is running with 1000 rpm and now we want to reduce the speed to 800 rpm. In that case, for some time the torque is gone to negative, and then the speed reduces from 1000 to 800, and then again the torque becomes positive and remains constant. So during this change from 1000 rpm to 800 rpm, the speed and torque both were changing. Therefore it is called as dynamic operation. So steady state as well as dynamic characteristics, we can achieve any desired operating point. Available in wide range of torque, speed and power. That is the second advantage. So now we know that electrical motors are available in the market of very small size, tiny size, and up to very large size. I have seen motor up to 4 megawatt, which are almost having size of the 1-story building or 2-story building, like that. And even tiny motors generally used in toys or in some precision instruments, dental instruments and all that, surgical instruments. So those are tiny motors. So these are available in wide range of torque, speed and power. So no other drive is available in such wide range. Means you can imagine automobile engines. So it is very difficult to manufacture a tiny automobile engine. There are so many components in automobile engine. Number of components. Or steam engines, we need to generate the steam, store the steam and all that, and coal is required to feed and all that. So that is, or any hydraulic machine is also impractical. Those are not available in such a wide range, but electrical machines are available. So that is again advantage. The third one is electric motors have greater efficiency. So this is very important advantage. They have very high efficiency. You can imagine any steam engine. It's a thermal system, so it is having very low efficiency. Then even IC engines are having very low efficiency. As compared to that, electrical motors are having very high efficiencies. Then unlike prime movers, the next one is, unlike prime movers, they can be ramped up and loaded instantly. Again, prime movers means the steam engines or like that. So they cannot be loaded or even started instantly. They require some time to start. Even IC engines require some time to start, isn't it? Suppose you are having bike or car, so you need to first declutch it, start it, and then you can load it. You cannot instantly load it, otherwise the engine will fail to run. So the engine must reach to some speed, only then it is able to deliver particular torque. So those are some requirements. So they cannot be loaded instantly. Then they cannot be ramped up, means very drastic changes in the load and all that are not feasible for those type of drives. But in electrical drives, that is possible. So these are some advantages of electrical drive. Again, there are so many. Means it is a clean system, eco-friendly and all that. Then again, characteristics can be molded into all operating quadrants, 4 quadrants. The 4 quadrants means first quadrant is generally, suppose you take y-axis speed and x-axis torque. Then first quadrant means positive speed, positive torque. That is called as motoring operation. Then the second quadrant, positive speed, negative torque. It is called as forward braking operation. Then the third quadrant, negative speed and negative torque. That is reverse motoring operation. And the fourth quadrant is negative speed, positive torque. So that is a reverse braking operation. So like that, these electrical drives can be